we're looking at note 6-1, square roots as inverses. So just to recap before we begin the new material, let's refresh. Find the inverse of number 1, f of x equals 2x plus 1. So we did this much earlier in the year, so let's recap on how it's done. So your first step is to rewrite f of x as y. So first step, rewrite f of x as y. So y equals 2x plus 1. And then you're going to switch x and y. So hopefully you're kind of remembering this. So x equals 2y plus 1. Okay, that was this step. So then you're going to solve for the new y. And again, like I said, this is something we have done before. So solve for the new y in this next step. So x equals 2y plus 1. So we're going to minus 1 minus 1. So we're going to have x minus 1, because you can't combine those two terms, equals 2y. And then you're going to divide both sides by 2. Remember here, of course, you're going to share the love with both terms in the numerator. So there's an implied 1 here, so this will become 1/2 x. Make sure that x looks like it's in the numerator like it was previous. Minus 1/2 equals y. So then you're going to rewrite y as y1 or f inverse of x if and only if, that is not spelled incorrectly, the IFF means if and only if, the new equation is a function. So you'll rewrite y as y inverse, that means inverse equation, or as f inverse, meaning inverse function, but you'll only use this notation if the new equation is a function. And this is a linear function, so it is legal to go ahead and say f inverse. So inverse function equals 1/2 x minus 1/2. And again, don't forget that x is in the numerator, not in the denominator. So hopefully this is just a refresher for you and you remember this. Okay, so now we're getting to the new part, number 2. So number 2 is f of x equals x squared. So this is quadratic, whereas this was a linear equation. So let's see how it changes. So you're still going to follow the same steps. Rewrite f of x as y. So we're going to do y equals x squared. Okay, we're still going to switch x and y. So this is going to be x equals y squared. Okay, and then we're still going to solve for the new y like we did here. So here in this case, I'm going to rewrite this because, of course, as you remember, to get y by itself, we're going to square root both sides. Okay, what I do to the left, I must do to the right, or vice versa. Okay, so here on the left, the square root of x will remain the square root of x, but the square root of y squared, remember, even index, odd power coming out, so that means you get absolute value bars. So in order to get rid of the absolute value bars, remember that means you put the plus or minus on the other side. Okay. So now let's look at our last step here. Rewrite y as y inverse or f inverse if and only if the new equation is a function. Is this equation a function? Well, hopefully you know that this is the square root graph. Okay, this is the square root graph. And it's both the positive and negative version. So the positive version of the square root graph, y equals positive square root of x, looks like this. Like this. However, the negative version of the square root graph looks like this. So when my answer is y equals plus or minus square root of x, is this a function? No, doesn't pass the vertical line test. So in this case, our final answer would look like this. Okay, we cannot use the F inverse notation like this because the new equation is not a function. All right, so let's look at something else. So in math, that can be kind of frustrating because we like our answers to be functions. So let's see what happens next. So example number 3. So on example number 3, we have f of x equals x squared plus 3, comma, x is greater than or equal to 0. Well, what that means is we're taking the quadratic parent function that has been shifted, let's see, up 3. Okay, shifted up 3, and then of course we would have left 1 up 1, and then left 2 up 1, 2, 3, 4. That's the quadratic parent function. Shifted up 3. But this is saying our domain that they only want us to look at is everything, x is everything greater than or equal to 0. So here's x is equal to 0, and this side of the graph would be everything greater than or equal to 0. This whole left side of the graph wouldn't be included because all of these dots are less than 0. So we're only looking at a portion of the quadratic graph, the right portion to be exact. So let's go ahead and find the inverse like we've been doing. So of course you're going to turn f of x to y. We're just messing with the equation, not the given domain. Okay, then we'll switch x and y. Then we'll solve for the new y. Okay, and like before, I'll rewrite this step. So you can see we're going to square root the left. Make sure you square root the entire left side. We're going to square root the entire right side. This right here will stay inside the radical. This, of course, will become absolute value. And then we have plus or minus square root of x minus 3 equals y. So let's examine this. So this is the square root graph shifted right 3. So 1, 2, 3. And we've got both the positive and the negative version. Right? That would be this piece, the positive version of the square root graph shifted right 3, and the negative version of the square root graph shifted right 3, or the reflected. I should really say that negative makes it reflect. So we've got both of these. But since we only are including the right half of the quadratic, remember that when we have inverses, graphically, they should be a reflection across the line y equals x. The line y equals x is our axis of symmetry, y equals x. Okay, so this is not a reflection of this if I include the whole thing. So that means I'm only going to include one portion of this, and the question you have to ask yourself is which portion? Would the reflection of this include the positive portion of the square root graph, or would it include the reflected version? So let's look at the ordered pairs. So this ordered pair 0, 3 would become 3, 0. This ordered pair 1, 4 would become 4, 1. This ordered pair 1, 2, 1, 2, 3, 4, 5, 6, 7 would become 1, 2, 3, 4, 5, 6, 7, 1, 2. So this section of the graph should not be included in my answer because of this restriction here. So that means my answer would be just this. Notice I put f inverse. Why am I allowed to put inverse function now? Well, look at the piece of the graph that's remaining. The piece of the graph that's remaining is now a function. I didn't include the reflected version, the negative version here, because notice that part would not be a reflection of just this part of the graph. So then let's talk real quick if this was like 3 part B. So what if the question was f of x equals x squared plus 3, where x is less than or equal to 0? Well, then of course that would be the leftmost portion of this graph. So that would look like 1, 2, 3, this, 1, 2, 3, 4. So that would just be the same exact quadratic from above, but the left side, x is less than or equal to 0. So of course, the math and all would follow exactly the same as above, because this hasn't changed, just this has. So the math is all the same. So you would get to the end where it says y equals plus or minus square root of x minus 3. And then again, you would select just the negative version of the graph, and that would be a function as well. Because of course, if you want that reflection across the axis of symmetry, you're talking 1, 2, 3, you're talking this bit of the graph. 3, 4, you're talking this bit. So isn't that the reflected bit of the graph? And wouldn't these be a reflection over the axis of symmetry? So, and again, now we have a function because we're only including a piece, not both parts. So isn't that quite cool? So here's your recap. So how to choose an answer sign. The right side of the quadratic will always produce a positive square root, whereas the left side of the quadratic produces a negative square root. For example, if f of x equals x squared, where x is greater than or equal to 0, meaning the right side, then the inverse function will be the positive version, the unreflected version of the square root graph. Notice the axis of symmetry, the reflection that you're seeing there, and how the domain and ranges switch. Okay, and likewise, if f of x equals x squared, where x is less than or equal to 0, in other words, the left side of the quadratic graph, then your function, your inverse function, will equal negative, the reflected version of the square root graph. And again, notice it's obviously a reflection across the axis of symmetry, as well as notice my domains and ranges have switched. Here it was less than, greater than, here it was greater than, less than, which makes sense because remember, inverses have domains and ranges that are switched. So that was our recap. That's dealing with quadratics. Now let's talk about finding the inverse of a square root graph. So this would be question number 4 because we made that 3A and 3B, correct? Yes, we did. Okay, so this is number 4. So same steps. Y equals square root of x minus 2. You see that minus 2 is not in the radical. So then we switch x and y, and we solve for the new y. So add 2, we get x plus 2 equals square root of y. Okay, so then I'm going to rewrite this because now I'm going to want to square both sides, square the entire left side, square the entire right side. So this is the quantity x plus 2 squared equals, now here in this case, when you square a square root, you do not get absolute value bars. Okay, it's only when you square root a square, not when you square a square root. So just be aware that you need to know that. All right, so no absolute value bars in this case. Here's our answer. Well, here's the question of the day. Is this a function? Well, sure it is. It's just a quadratic graph. It's a quadratic graph shifted left 2. But let's think about this really quick. Maybe I want to put it up closer here. Okay, let's think about this for a moment. Okay, the original function was a square root graph shifted down to, so that would be right here, and right there, and 1, 2, 3, 4, 2. Okay, that's our square root graph. All right, and so that's the upper version, not the reflected version, right? That was a positive there. All right, and now here we've got a quadratic graph shifted left to, correct? But if I graph this entire quadratic graph, we're going to have a graph that looks like this. Okay, remember that A inverse should be a reflection across the line y equals x. Okay, when I invert a square root, you're going to get an answer of a quadratic, but you don't want to keep that entire quadratic. You just want to keep the portion that would be a reflection on our axis of symmetry of this piece. So just like going the other way, the vice versa way, if we've got the positive version, not the negative, but the positive version of the square root graph, then we're going to keep the right side of the quadratic. So I want to do away with the left side of the quadratic. I just want the piece that would be the reflection. Notice now that's a beautiful reflection. So yes, it's an inverse function, so we're going to keep the function notation. We're going to keep the equation of the quadratic, but of course, like the problems in the previous problems, we're going to restrict the domain to be the right side of the graph. So from the vertex, which is -2, and everything greater, that would include the right side of the quadratic graph. So that's going to be your answer on this guy.